Alright, welcome. Today we'll be talking about absolute value functions and their graphs. Okay, so an absolute value function. So the parent function is the absolute value right here. It should have straight up and down lines. Now these numbers or these symbols you will find above the enter key when you press shift and then that button right there, and you'll get those right there. Okay, so the function basically, in its original state, the function is going to have a domain of all positive numbers, okay, which is y is let me see, alt y is greater than or equal to 0. Okay, so that's, well, no, that's the range. Jeez Louise, I always screw this up. I always mix those two up. Okay, so the range is going to be all positive numbers. Why? Because this is just the distance from 0. So absolute value is just going to be the distance from 0. Now the domain is going to be all real numbers because you can plug in anything. There is no specification on what numbers you can or can't plug in. Okay. Now, if we were talking about a different type of graph of y equals the square root of x, okay, now its range would be all positive numbers, okay, but its domain would be all positive numbers. And this is a very similar function to the absolute value graph. Its domain is going to be all positive numbers because you can only plug in positive numbers in for x. Okay, but we're going to ignore that for now. We're just going to go ahead and, well, shoot. Let's go ahead and see if we can erase it all. There we go. So we're just going to ignore that for now. So we're just working on the absolute value function. Alright, now the other thing is too is when you're working with this, just to talk about the functionality, when you're working inside of the absolute value braces, okay? Alright, so let's write it out. X plus 7. Now let's go 8 plus 7 brace plus negative 9. Okay, everything out here can be negative, and that will affect the actual overall positive or negative value of this. However, everything in here you're going to treat as its own separate parentheses. Okay, so now if we made this a negative 8 plus 7, we would get a negative 1, which is okay, because we still have the absolute values and we still haven't done it yet. But when we do the absolute value, this is going to turn into 1, and then you're going to add the negative 9. Okay, so while you're working in here, it's totally fine to do stuff, but when you get down to one number, you need to treat that as you're taking the absolute value of that number. Don't change anything until you get down to simplifying the inside of the absolute value to one number. Okay, I've seen a lot of people make mistakes on that. So please understand, here's all the rules with it. Now, the interesting part is that, no, we won't talk about that right now. But just everything's all set up like this. Now the actual graph and what it looks like, we can actually graph. So we go y equals absolute value of x. Okay, so you type it in, you're good to go. Alright, now if I do add some numbers in here, let's put some numbers in here. Let's put an a here, a plus h here. And if you remember in our family of functions when we talked about this, okay, so we'll add all. Okay, so everything's all set up. Change that to 0. There we go. And let's change this to black. That's easier to see. Okay, alright, so there's our absolute value function graph. Okay, this controls the vertical stretching, the vertical compression. If it's less than 1, okay, if we stretch it out, it's going to be greater than 1. It's going to be really kind of skinny. What it's doing is, and if I take a look at the values as we go, as I increase these values, the y values increase greatly. Okay, so the bigger I have the number in front multiplying, the smaller the y values are going to be. So if I have it less than 1, those numbers are going to be less than usual. Okay, now if I make them negative, obviously they're going to go in the other direction. So that's kind of helpful to know, especially from the graph concern. Alright, now if I add numbers inside of the absolute value equation as I graph, it's going to give it the illusion of moving to the left. Okay. Alright, now this one is a particular, and if you look at it, I'm plugging in those same 5 values in those spots. Okay, if I make it negative, I move it to the right. If I make it positive, I move it to the left. Okay, what's actually happening is I'm changing the y value. Okay, so as you can see, it's pretty straightforward right here, but as I change it, the y values just become a lot different. Okay, they're going in the other direction. It's almost like they're going up in the opposite direction of what I want. Okay, so you just have to be careful as you're working with this stuff. Just understand as you add numbers inside of the graph of an absolute value, you are going to add numbers, you move it to the left, subtract numbers, you move it to the right. Okay, now if I add numbers outside, I'm just increasing all the values. So it gives it the appearance of moving up, which it does. Okay, whereas if I make them negative and I subtract from them, they move it down. Okay, this one is always going to be backwards. And as you can see, it kind of looks kind of cool, like some beads and stuff. Alright. Alright, now, just talking about the nature of it, this would normally, here, let me go, equals. This would normally be a straight line if it wasn't for the absolute value. Okay, so here, if we take a look at both, let me get rid of that, and let's go back to y equals the absolute value of x. Okay, it would be normally a straight line. So they both have the same values, blah blah blah, straight line, and then all of a sudden this one continues on going down, and this one goes up. Well, the reason why it goes up on this like rebounding shot, it's almost like it hits the x-axis and goes between, you know, like a comic book effect bullet or something, is because the values are now constricted to just being positive. Okay, it can only be positive, so we're getting the same number, we're just getting the positive version. Alright, so if we press enter and we put in, let's go up. Let's go -3. Okay, we should get out of -3, but we get a +3. If we plug in a -4, we should get out a -4, but we get a +4. So that's some interesting stuff to just see right there. It's like no matter what I plug in, I'm going to get a negative. I'm going to get a positive version. Okay. All right. So that's another interesting way of why this has this kind of angle, and it is actually closely related to y equals x because it is y equals x. It's just y equals x, and then it also has this same slope going this other way. This is y equals -x slope. So it's actually very interesting how it works. Alright, that's it for today, talking about our absolute value functions and graphs. You guys have a wonderful day, and I'll talk to you later.